Welcome back, students. In this video, we'll be doing the first question of exercise 1.4 section B. But before we proceed with this exercise, what you need to understand is from these theorems 1.5, 1.6 and 1.7, which is in your page 16 to page 18, okay, Nbse. So what this tree theorem actually means the same thing, but what it is trying to tell us that if we have x is a rational number, which is obviously in the form p by q, right? By now you already understand what a rational number is. So p and q, these are going to be both integers. So suppose you come across a rational number like this, okay, where p and q are co-primes. Clear? Are co-primes. So by co-prime, you understand it is referring to those two numbers whose only common factor should be 1. Okay, in the sense 2 and 5, these are both co-primes because the common factor that they have is 1. Because 2 and 5 are both multiples of 1. Apart from that, there's no other number that divides these two, right? Similarly, for 3 and 11, this is the common factor is also 1. Now you look at this, it does not necessarily mean that p and q should only be a prime number. Okay, I can also give numbers like 5 and 9. See, the common factor between 5 and 9 is going to be 1. Or you can just take numbers like 5, 9 and 13. Okay, 9 is definitely not a prime number, but the co-primes, or the factors of this tree number, the common factor is always going to be 1, because 5 is only divisible by 5 or 1, 9 is divisible by 1, 3 and 9, but not with 5. The same goes with 13, clear? So p and q should be co-primes, alright? Okay. So, and then suppose 3 and 6, these two is the common factor between these two is going to be 1 and 3 as well. So this is not a co-prime, alright? 3 and 6, I hope you're getting. The same goes for 5 and 15. Here, these are not co-primes because the common factor is 1, 5, yes, okay? This, you see, both of them can be factorized with 5 as well. So this is not a co-prime, okay? So I hope you're already clear with what a co-prime means, alright? So that is what all this tree basically tells us, okay, that p and q is a rational number, where p and q, definitely you know that if it's a rational number, then by default it has to be an p and q have to be an integer, and most important thing is p and q are co-primes, and if q, okay, can be expanded, or it's a q is in the factorization of the form 2 to the power and 5 to the power m, okay, in this, okay. So if q is either of this both form, or if it is of just 2 and, or if it is in any one of these three forms, right, then we say that the number will be a terminating, it will terminate, okay, the number will terminate, okay. I hope you are clear with this. It will terminate, okay? We can say that a number will terminate. Okay? So remember, it should be first a rational number. So p and q should be co-primes, okay? That means the common factor that between p and q should only be 1. Next thing is, if q, that is the denominator, is of this form or this form, in one of these three forms, if the denominators can be expressed this way, then the number will terminate. Okay, and if the denominator is not of any one of this form, okay, then definitely the numbers will not terminate. Okay, I hope you're clear. Okay, by terminating, what we understand is after certain steps of division, it will come to an end. Okay, terminate means end, right? It means end, right? So for example, 0.33, this terminates, right? Because after 3 we don't have any number. Even 4, 7, this number terminates, right? When we talk about numbers like 0.365239, okay, we come across certain numbers. See, this dot implies that the number keeps on, the number is not ending, okay, there's no end to this number. So such kind of numbers are called non-terminating, okay, does not end, the number will not end even when you divide, okay, right? For example, if you were to divide 10 and 3, right, for example, 10 divided by 3, you take 0.33333, right? If you keep on repeating, these are numbers that don't terminate, right? This is just one example, okay? So, alright? Clear. So you just keep this in mind, okay? These important things about how p and q should be co-primes, and q should either be in 2 to the power n form, or either 2n or qn form. Only if q is in one of these forms, then the number will terminate. Clear? Now, we have already come across terminating and non-terminating repeating numbers already in class 9, okay? So, terminating, you understand, we're talking about numbers or decimals that will end at certain point of time, okay, after certain division. Non-terminating means it will not terminate, okay? Clear? Alright, and what do we mean by non-terminating repeating? For example, look at this number. This does not terminate, but it is repeating, right? 333 keeps on repeating. Or example, 3125, 3125, 3125. Suppose you get this, okay? This does not terminate. You agree or not? It does not terminate. There's no end to it. But it's repeating. What is repeating? 3125, 3125, 3125, okay? So this is what we understand by non-terminating repeating, okay? That after the decimal point, the numbers that occur after the decimal point will keep on repeating. So right now, first thing is we are supposed to find out if this number, rational number, is terminating or not. So obviously it's a rational number, first thing, right? Because this is of P by Q form. 13 is an integer, because the idea of a rational number is that P and Q should both be integers, right? So P is integer and Q is also an integer, right? Now let's try to find out the factorization of, remember Q should either be in 2n 5m or 2 to the power n or 5m for this given rational number to terminate, okay? It should be in one of these forms. So let us just check, okay? 3, 1, 2, 5. So if we take 5 times 6 is 30, 5 times 2 is 10, and 5 times 5. Now you get 5 times 1, 5 times 2, and 5 times 5. So 5 times 2 and 5, and 5 times 5, okay? So after this, 5 times 1. Therefore, what do we understand by this? Therefore, 3, 1, 2, 5, okay? Which is 1, 2, 3, 4, 5 times, okay? So it is 5 into 5 into 5 into 5 into 5 times. But instead of writing this, can I write it as 5 to the power 5? Yes, okay? So since this, therefore, you can always write since 13 by 3125 is actually the same thing as 13 by 5 to the power 5. So it terminates, okay? It terminates. Clear? Because we found out that Q is if of this form, 5 to the power m. Remember when we say 5 to the power m, m is also going to be any number, okay? Any number. Clear? Same thing goes for n. N is also going to be a number here, okay? They have just, because they have just given m and n as a notation. Remember that, okay? So this is 5 to the power m. Clear? So that means this will terminate. The next question that we go, this is fairly easier. So here again, we need to make sure that Q, which is your denominator, should be in this one of these three forms, right? So 8, we'll focus with 8 is nothing but 2 into 2 into 2, which is 2 to the power 3. Therefore, 17 by 8 can also be written as 17 by 2 to the power 3. So therefore, the number terminates, okay? Or the rational number terminates, clear? Because here Q is in the form 2 to the power n. Clear? Remember again, n, okay? It's going to be any numbers. Clear? So when you write 2 to the power n, we talk about all the different possibilities. 2 to the power 1, 2 to the power 2, 3, 2 to the power 4, 2 to the power 5. This is what we go, okay? What we say, it can be any number. n, okay? So these are all the values of that can be taken up by n. Let's go with this number, okay? So we have this 455. So first let's try to find the prime factorization of 455. So I will start off with 5. So 5 times 9 and 5 times 1, 7 times 13. So this is going to be 5 into 7 into 13. Therefore 6 to the power 4 divided by 455 is of the form 64 divided by 5 into 7 into 13. Therefore, the number does not terminate. Okay? Clear? Okay? So, let's go with the next question, which is this, okay? Just give me a second. Okay. Okay? Now you look at this. Now let's try to find out 1600. I'll just do it this way. Okay. Now one more thing. You look at this. let's just try to first write this down, okay? Remember what is the given equation, the theorem which tells us that P and Q must be co-prime. But you look at this number, focus on this number. I think this number is divisible, right? They have common factors. Yes? Okay, so since they have common factor, what is the common factor between them? Is actually 5, okay? 5 is the common factor, so let's cancel this out first, okay? Remember, P and Q must be co-prime here. So when we talk about 15 and okay, they are not co-primes, clear? 15 and 1600 are not co-prime because the common factor between them is not just 1 alone, it's even 5, okay? So let's just write this as okay, 15 and 1600, okay? So 5 times 3 is 15, 5 times 3 is 15, so it's 320. And then after this, I don't think it's possible, 3 and 320, not possible. So we have 3 by 320. Clear? Now you see 3 and 320, the only common factor between 3 and 320 is actually 1, okay? So we can proceed with this, okay? Clear? So now instead of doing this, we will write this as 320. So we can take 5 times 6 is 30 and 5 times 4. 2 times 3, 2 times 2, 2 times 16, 2 times 8, and then 2 times 4, 2 times 2. Therefore, 320, okay, see, they should be co-prime, remember that, okay? So 3 and 320s are co-prime now because only common factor between these two numbers is 1 alone. So 320 can be written as 5 to the power 1 into 1, 2, 3, 4, 5, 6. So straightforward, I'll write it as 2 to the power 6, okay? Clear? So therefore 3 by 320, okay, is the same thing as 3 by 5 into 2 to the power 6. Therefore the number terminates. Clear? Because remember, Q should be in one of those 3 forms. So this is in the form 5 to the power n or 5 to the power m into 2 to the power n, okay? So therefore it will terminate. Next question is this, okay? Now let's see, first 29 and 343, these are going to be co-primes because 29 is a prime number. The only common factor between 29 and 43 is 1. So 343, in fact, it is going to be with 7. 7 times 4 and 7 times 9, okay? So 7 times 7. Therefore 343 is nothing but 7 into 7 into 7, which is same thing as 7 to the power 3, okay? Therefore 29 by 343 can be written as 29 by 7 to the power 3. Therefore the number it does not terminate, okay? Clear? Quickly moving on, we'll go with this. Here clearly you can see here, so therefore it terminates, okay? It terminates, yes, because again same thing, right? Q, this is Q should, it tells us, the theorem tells us that Q should be of the form 5 to the power 2 to the power n. So since Q is already of this form 2 to the power 3, 5 to the power 2, so therefore it terminates, okay? For this, again you look at this here, first thing, here it will not terminate, okay? It will not terminate, okay? So see, but before you conclude your answer, because this is definitely not in the form, see, remember, okay, Q should only be of those 3 forms, clear? Either 2 to the power n or one of these 3 forms, okay? So suppose you come across these questions like this, you first check whether this 129 and 2 to the power 2, 5, whatever is in the, check if the numerator and the denominator is a co-prime or not, okay? Clear? So one way to check is 2, does 2 divide 129? No, okay? 5, definitely no. 7, no, okay? So that means it's a co-prime. Now let's go with 6 and 15. You look at this, are these co-primes? No, 6 and 15 are not co-primes because they have a common factor, which is 3. So I'll just write this 5 into 3, so you can cancel out 3, so 2 by 5. Therefore it terminates, okay? Because this is of the form 2 by 5 to the power 1. Clear? Just make sure that easy questions like this, you need to make sure that the numerator and the denominator should be co-primes, okay? Alright. Because see, you look at this, if you're not careful with this, what some of you will do here is that you'll write this as 15 can be written as 3 into 5, right? So you'll write this as 6 into 3 into 5. And some of you will only focus on the denominator and you'll say since, and then you'll write it does not terminate, right? Because you'll be saying, or you might be thinking that since this is not in one of the 3 forms, then it will not terminate, okay? So you need to make sure that your numerator and your denominator is a co-prime. Let's go with this. Now, even with this, 35 and 50, they are not co-primes, right? Because both of them have a common multiple, which is 5. So 5 into 10. So you can cancel out 5. So you'll be getting this as 7 by 10. And 10 can be written as 2 into 5. Therefore, 7 to the power 10 is 7 divided by 2 into 5. So the number will, it terminates, okay? It terminates. Moving on to the last question, we have this, okay? So 210 and 7, you check this, 77 and 210, these are not co-primes, okay? Because 7 times 1 is 7, 7 times 1, 7 times 30. So 11 by 30. You see, 7 and this, they are not co-primes because they have a common factor which is again 7, okay? So now 30 can be written as 5 into 6. So this can be written as 5 into 2 into 3. Therefore, 11 by 30 is equal to 11 by 5 into 2 into 3. Therefore, it does not terminate. Okay? Clear? So I hope you're clear with this. Okay? So we shall end the video here.